Please note that this podcast is in support of Ukraine and Europe, so our conversation today will reflect that. We have some breaking news. Chernobyl loses all power amid Ukraine conflict. The IAEA is on alert. The International Atomic Energy Agency said that several Ukrainian electrical substations, which are vital for nuclear safety, were affected by military activity. Power lines to other nuclear plants were also impacted. Today is Tuesday, January 20, 2026. Before we go any further, please consider subscribing to Defense Reports. It's your go-to source for timely, in-depth military and defense reports. I'm Alex, and with me is Aria for the latest deep dive by Defense Report. We do sharp, no-nonsense breakdowns of global defense news, military tech, and strategic developments. And today we are covering a terrifying new reality.
It really is. We're talking about something defense analysts have modeled for years. You know, a worst-case hypothetical in a sim room.
And now it's real.
Unfortunately, as of the early hours of this morning, yes, we've moved from hypothesis to a live fire exercise involving the most radiologically contaminated site on Earth.
Okay, so we need to cut through the inevitable panic of the headlines and really look at the mechanics of this. The how here matters just as much as the what. But first, let's set the scene. The physical reality on the ground.
Right. It's important to understand Ukraine is in the grip of a severe deep freeze right now.
We're talking temperatures between -15 and -20 degrees Celsius. It's just brutally cold.
Which is the absolute worst possible environment for an electrical grid. At those temperatures, you're not just dealing with cold, you're dealing with physics. Metal contracts, lines get brittle.
And the load on the grid just spikes. Everyone is trying to stay warm. The system is already stretched thin.
Exactly. And into that brittle, high-tension environment, the Russian Federation launched a massive combined attack. Drones, missiles, and they were specifically aimed to hit the nuclear backbone of Ukraine's energy grid.
The timestamp that matters here is 04.0 a.m. local time. That is when the monitors at the Chernobyl nuclear power plant just flatlined. The site went completely dark.
And let's be very clear for everyone listening, went dark in this context. It doesn't mean the lights flickered in a hallway.
No.
This means a complete loss of off-site power. In industry terms, a LOSP. For a normal factory, that's downtime. For a nuclear site, even a decommissioned one like Chernobyl, that is a Tier 1 safety event.
You're immediately on the clock.
Instantly. You are forcing the safety systems that contain the remains of Reactor 4 onto emergency diesel backup. It effectively puts the safety of the continent on a countdown timer. A timer determined by fuel reserves.
And looking at the targeting data coming out of Kyiv, this wasn't a stray missile. This looks deliberate. A specific doctrine in action. I was reading the analysis. They're bypassing the actual power plants to hit the distribution nodes.
You're seeing that correctly. Military intelligence circles are already calling this substation warfare.
Substation warfare.
It's a deliberate shift in Russian strategy. Instead of hitting the heavily hardened power plants themselves, which is also, politically risky, they're targeting the transmission nodes. They are trying to carve the Ukrainian grid into what engineers call energy islands.
Let's break that down because energy island sounds almost harmless.
Yeah.
But the implications are catastrophic. It's basically desynchronizing the grid. So even if a plant is making power, it has nowhere to go. Is that right?
That's the goal. The entire grid has to operate on a perfect frequency, 50 hertz in Europe. If you destroy the substations that balance that, safety relays at the power plants trip to protect the generators from burning out. The plant has to disconnect itself to survive.
So you create a total blackout.
In -20-degree weather. The goal is to force capitulation. It is the weaponization of thermodynamics.
And in this strike, the linchpin was the 330 kV Slavutich substation. I looked at the grid map. That's not a random node. It feeds the Chernobyl plant and, crucially, the city of Slavutich itself.
Which creates a dual crisis. You cut power to the nuclear site, forcing it onto vulnerable generators. But you simultaneously black out the city where the entire workforce lives.
So the very people who have to manage this nuclear emergency are sitting at home, in the dark, freezing.
It's a psychological siege combined with a kinetic strike. It's brutal.
We have to get to that human factor because I think it's the most underreported part of this story. But first, let's stay on the ballistics. I saw a report from Serhiy Beskresnov, the expert known as Flash. He called this a game of missile roulette, which really stuck with me.
He is spot on with that. When we talk about targeting these substations, they aren't miles away in an empty field. These huge switch yards are often located right on the perimeter of the nuclear plant. We're talking maybe 300 to 1,000 meters from the reactors.
300 meters.
Yeah.
The hypersonic missile, that's effectively zero. I mean, the margin of error alone.
That's the variable. The CEP, circular air probable. It's the radius where 50% of your missiles are expected to land. Now, Russia markets weapons like the Iskander and the Kinzhal as high precision, but the war has shown us the reality is much, much sloppier.
We've seen them hit apartment blocks when they were aiming for a factory down the street.
Exactly. We've seen guidance failures, jamming, throwing them off course.
Ah.
So you do the math. You aim a Kinzhal at a substation 300 meters from a reactor, and your guidance system drifts by just 0.5%. You're not just missing the target.
You could be slamming that warhead into a containment building or a spent fuel pool.
And that's exactly what Bezkresnov warned. He said this creates the potential for a second Chernobyl, not through intent maybe, but through sheer gross negligence in targeting.
It's reckless endangerment on a continental scale. They are firing heavy ordnance into a nuclear China shop.
A China shop is putting it mildly.
I want to address a question that I know is on a lot of listeners' minds. We hear it every time Chernobyl is in the news. The plant is shut down. Why does it need power? We need to clarify the difference between shut down and safe.
It's a critical distinction, a very common misconception. Just because a reactor isn't making electricity doesn't mean it's inert. The Chernobyl site still holds around 20,000 spent nuclear fuel assemblies.
And that fuel is still hot, radiologically.
It is. It generates decay heat. It requires active cooling and management. But honestly, the fuel pools aren't even the biggest immediate problem right now. The real ticking clock is the new safe confinement, the NSC.
The giant arch they slid over the ruins of Reactor 4 a few years back, the largest moving structure ever built on land.
That's the one. Cost about 1.5 billion euros, taller than the Statue of Liberty. Designed to seal in the radioactive dust for a century. But here is the critical piece of information that often gets buried. The NSC is already compromised. It's broken.
This goes back to that drone strike in February of 2025, right?
Yes, less than a year ago, February 14th. A Russian drone with a high explosive warhead hit the roof of the NSC. It tore a 160-square-foot hole in the structure.
But the hole was just the start of it.
Right. The impact was one thing. The fire that followed was another. It burned through the outer membrane, the waterproofing layers. It did severe damage.
And the IAEA confirmed this just last month.
They did in December 2025. Their report stated the NSC has, and I'm quoting here, lost its primary safety functions. Specifically, its confinement capability. It is no longer an airtight seal.
So we have a punctured shield, and now this substation attack has cut the power to the life support systems for that broken shield. What physically happens inside that structure when the fans stop?
Well, it comes down to two main things: radioactive dust and hydrogen. The NSC is designed to run on negative pressure. Huge ventilation fans are constantly sucking air in so that radioactive dust can't blow out.
So when the grid fails, those fans stop.
And the negative pressure collapses. The containment just becomes passive. If the wind blows the wrong way, that dust can escape through that huge hole in the roof.
You also mentioned hydrogen. It sounds more volatile.
It is. Inside the shelter, the high radiation levels are constantly splitting water molecules in the air. It's a process called radiolysis.
And that creates hydrogen gas.
Exactly.
Yeah.
In a stagnant environment, without ventilation fans running to cycle the air, that hydrogen can build up in the headspace of the arch.
And hydrogen in a confined space? That's an explosion risk. We're talking Hindenburg territory.
You do not want a hydrogen explosion taking place inside the structure covering the remains of the reactor core. That's why the power is absolutely non-negotiable. You have to keep that air moving.
Okay, so the grid is gone. The standard procedure is to switch to the emergency diesel generators, the EDGs. Every nuclear plant has them. So, in theory, we should be okay.
In theory, yes. And Chernobyl did switch to its EDGs immediately. But this is where the logistics of a war zone collide with safety regulations. International standards say you should have at least 10 days of fuel on site.
But they don't.
Intelligence reports suggest Chernobyl's localized reserves might be as low as 48 hours.
48 hours. That's a blink of an eye in a crisis.
Yeah.
And then you have that minus 20-degree weather again. It's not just about running out of fuel, is it? It's about the fuel itself.
Exactly. Diesel is temperamental. In extreme cold, unless it's properly treated, it starts to gel. Paraffin wax crystals form, it clogs the filters, and it starves the engine. This creates a risk of what engineers call a common mode failure.
Meaning that because all the generators are in the same cold using the same fuel, they could all just die at once.
Precisely. You lose all your redundancy because the failure point is environmental. And you can't just call up a fuel truck. The exclusion zone borders Belarus. It's a highly militarized area. Drones, artillery threats, trying to drive a fuel convoy in there during a blizzard under fire. It's a logistical nightmare.
So every single layer of the safety strategy is being stripped away. The grid is cut, the backup fuel is low, the machinery is fighting the cold, and the protective structure itself is already leaking.
And that brings us back to the human element, the biological component of the safety system.
The workers, the people in Slough.
Yes. The IAEA has been warning about this for months. They call it the deterioration of living conditions, which is a very polite way of saying these people are suffering. Imagine you are a control room engineer. The substation strike didn't just hit your plant, it blacked out your home.
So you're there, it's -20 outside, your apartment has no heat, no water, you're worried about your kids, your parents. You haven't slept because of air raid sirens.
And then you have to go to work and make critical split-second decisions about hydrogen levels and voltage regulation. Your cognitive performance just plummets from the stress and the cold. It's unavoidable biology.
It's decision fatigue. You can have the best safety binder in the world, but if the person reading it is exhausted and freezing and terrified for their family,
then the protocol fails. The mental state of the workforce is a critical safety system, and right now, that system is under a coordinated siege.
And this isn't just happening at Chernobyl. We have to look at the wider pattern. Zaporizhzhia nuclear power plant has been on the brink for years. This feels like the same playbook.
It is the same playbook. ZNPP has lost external power 11 times since the invasion began. 11 times they have had to roll the dice on those emergency diesels.
And right now, ZNPP is also hanging by a thread, isn't it?
A single 750 kV line. That's it. The backup 350 kV line there was also damaged recently. The IAEA Director General, Rafael Grossi, said the grid is in its worst condition yet. There is no margin for error left.
The timing of this strike, January 20th, it's not random. It coincided perfectly with the World Economic Forum in Davos.
Of course not. It's a message. Analysts are calling it energy-side. It's a deliberate signal to the West. President Zelensky confirmed it. He said targeting these energy islands is designed to create a humanitarian catastrophe to force leverage at the peace table.
It's holding the entire continent hostage. Give us our terms, or we let the cooling fans on the reactors stop.
That's the subtext. It is nuclear blackmail without actually using a nuclear weapon.
Now, we do have a small update on the immediate situation. Reports indicate power was restored to the Chernobyl site on the evening of January 21st.
It was. The plant ran on those diesel generators for about 16 hours before they reconnected the grid.
So, we can breathe a sigh of relief.
A very, very shallow one. Don't mistake restoration for safety. The grid is fragile. The new safe confinement is being held together with temporary patches. We mentioned the big hole.
Right.
But there are over 300 smaller holes in the structure from the firefighting efforts back in 2025.
300 holes. It's not a shield anymore, it's a sieve.
It's a compromised membrane. And the plant director, Serhiy Turkhanov, issued a stark warning today. He said the structure is so degraded that even a nearby detonation, not a direct hit, just the shockwave, could cause the old sarcophagus inside to collapse.
So we are right back to missile roulette. Even with the power on, a missile landing close enough could bring the whole thing down.
We are relying on a fragile wire stretching across a war zone to keep the fans running. We are relying on the precision of missiles that are known for their inaccuracy. And we're relying on the mental resilience of a workforce that is being systematically frozen out of their homes.
It really makes you reconsider what nuclear safety even means. We think of it as thick concrete walls and high-tech sensors, static things.
But this event showed us the reality. Nuclear safety is a logistics chain. It's a supply of diesel that doesn't gel in the cold. It's a warm apartment so an engineer can sleep. It's the integrity of a substation 50 miles away. When you take those things away, the concrete walls don't matter much.
So as long as the substation warfare continues, we are just rolling the dice every single night. The question isn't just, will the power go out again? It's how long until the diesel runs out?
Or a generator just fails to start. That is the question keeping the IAEA up at night. And considering the stakes, it should be keeping all of us up, too.
You've been listening to Defense Report by Alex and Aria, where we analyze the latest in military strategy, global defense, and advanced weaponry. Subscribe to Defense Reports, your go-to source for timely, in-depth military and defense reports. We'll catch you next time.